Hello and welcome to my poster. My name is Jorge Uquillas. I'm a postdoc in Jan de Boer's lab. And today I'm going to talk to you about UltraClean, which is a decellularized off-the-shelf human allograft for anterior cruciate ligament reconstruction. What is ACL? ACL joins together the femur with the tibia. Its function is to give stability to the knee and prevent anterior movement of the tibia with compared to the femur. The ACL can be broken in non-contact sports like football, basketball, hockey, when the athlete or the person who's playing the sport changes direction suddenly and pivots really fast. In this case, the intercondyle notch in the femur acts like a scissor that can cut the ACL at the tendon proper or at the femoral insertion. The surgeon in these cases, when evaluates the lesion, he or she can use patellar ligaments or hamstring quadriceps tendons to replace the damaged ACL. In this case, he will take a healthy tendon, whether the patellar tendon is used or the hamstring or the quadriceps tendon from the healthy knee, and put it in place for to replace the broken ACL. This causes donor site morbidity, extended physical therapy, but most importantly, an ACL is not replaced by another ACL but by a tendon. Tendons and ligaments have different mechanical properties, different biological properties, and these can have problems at the end of the day with the graft re-rupture and instability of the knee. What we want is to create a decellularized allograft from cadaveric donors that can be used to circumvent these problems. We will evaluate biological, biocompatible, and biomechanical properties and compare UltraClean with the native counterpart to evaluate whether the UltraClean is a suitable option to autografts. One of the first things we did was to measure DNA content. DNA content was markedly decreased between the native ACL and compared to UltraClean with a 98 removal of host DNA. Also, we wanted to compare and measure the glycosaminoglycan content and the collagen content because both are important ECM molecules that give the ACL its viscoelastic properties. We saw that there's no significant change between collagen and glycosaminoglycan content, which is nice for us because we can conclude that the decellularization process do not remove important ECM proteins or molecules. The ACL, when we tested, was attached with the tibia and femoral bone blocks to allow easy mechanical testing, uniaxial mechanical testing. But before that, we took windows and small pieces of ACL and put them through a biocompatibility test and viability test with the tenocytes. After 7 days in culture, most of the cells, whether they were seated on top of native ACLs or ultra-clean ACLs, showed 100% viability, and the cells actually grew at the same proliferation rate between the both materials, either the native or the ultra-clean. As you can see in the SEM images, where cells artificially colored can spread and proliferate and deposit ECM on the materials. But most importantly, as I said, the mechanical properties were not changed during the decellularization process, as you can see in one of the representative samples, in this case, sample number 8. The mechanical properties have the same shape of the curve, as well as same maximum failure load, and we have also calculated the same Young's modulus and maximum stress. So we're happy that the biocompatibility, the biological and the biochemical properties between native and UltraClean remain the same. And we're confident that the UltraClean represents a promising alternative as an allograft for ACL repair and revision surgery that the surgeons can use to treat their patients safely. Thank you.